All right, we are doing one of the two studies in the Cambridge Psychology syllabus that deals with animals. The other one is Yamamoto et al., dealing with how primates could help each other in certain social situations. This one here is in the learning unit. It's regarding a parrot and his ability to distinguish similarities and differences between objects. So, because we're dealing with animals, if you have not familiarized yourself with the ethical guidelines when using animals, I recommend you do so before watching the video. There is a short video that I created about this that you could find linked to this video. All right, so let's get started with a basic starter question. When you think about animals in research for psychology, you often might think of something like Pavlov or the pigeons used in Skinner studies, or maybe some dogs used for learned helplessness and things that are very famous studies. When we talk about animals in psychology, we usually just think about things like operant conditioning. So how do you get a dog to learn how to sit? You do various things that motivate the dog. You could give it a treat. You could remove something it doesn't like. You could use presentation punishment, or you could remove something that the animal likes. Two of these things are more preferable, of course, because you don't want your study to be unethical. Especially nowadays, people are very concerned about animal rights, more so than when the study was conducted in 1987 or any of the other studies that are famous for using animals. So let's just have a quick review of learning theories before we get to the study. Both of these learning theories are relevant. One, again, is operant conditioning, and the other one is social learning theory. And if that doesn't ring a bell, hope that picture does. Go back to the Albert Bandura study on imitative learning. He coined the phrase social learning theory, how we learn by watching others. Both of these learning theories will be present in the Pepperberg study on how to tell differences between objects. Excuse me. So Bandura is mentioned by name, so it's part of the background of the study. I'm not going to go too far into social learning. If you're not familiar with that study, I highly recommend you check out the video on social learning and Bandura. All right, so let's start with a basic question. Communication versus language. What is the difference? We have no doubt that animals try to communicate with us. Your dog wants to go for a walk. It kind of, takes the leash off the counter and puts it in his mouth. Or, somebody wants food. It's, meowing by the food tray. So there's no doubt that animals communicate. What there is doubt about is if we could attribute language, or we can give animals language, or if animals have an innate language already present. So if you don't know what language is, it's probably something you don't think about very often, but if you're interested in linguistics, a very simple way of putting it is that language is different from communication in that it uses arbitrary symbols, abstract representations to convey meaning. So in other words, the example that's very classic is the word tree, T-R-E-E. There is nothing in those four letters that indicate a tree. It's an arbitrary representation of a tree. So if you give it to somebody who's never been exposed to English, they would have no way of deciphering what its meaning actually is. So the language is completely, again, that key word is arbitrary. So previous studies have shown that primates, which animals that are very similar to ourselves, are capable of having some sort of symbolic language. And here is a good example. David Premack and several other famous researchers did a lot of research on primates to show that they could indeed grasp language. So this example here, here's the key on the left side. They're very abstract. Maybe the first one isn't, because the first image looks like a monkey, but the other ones don't resemble their meaning. So I believe this one says, Sarah, insert the apple into the bucket and place the banana on the plate. So David Premack, who is mentioned several times in the source article for Pepperberg, says that we do not attribute language to non-primates. So Pepperberg says, challenge accepted. Let's see if we can demonstrate true language. Now, what do I mean by true language? Now, you could argue that if you're imitating sounds, you're just using conditioning. So if a child says something like bottle or milk or something else that's very simple, are they actually understanding that the word has an arbitrary symbolic representation, or is it just doing it through maybe some sort of conditioning? I make this sound, I get this thing. Very basic behaviorism. So we have to find a way, this is the real challenge, of seeing if there's any sort of true language involved with the study. Does the animal actually comprehend the word coming out of his mouth? And this reminds me of many philosophical arguments or thought experiments that have been done in regard to computers. So the example I use is the very famous thought challenge of the Chinese room. And the Chinese room is pretty much about a computer, but we could apply it here to animals, where if you if you put somebody in a room that doesn't know any Chinese, but you give him the resources to answer questions, the person on the outside of the box may actually be fooled into thinking the person on the inside is fluent. And that's the same thing with computers. We might be fooled into thinking there's actually an intelligence behind the information that is being put out. So the real challenge here is finding a way to not just have the animal identify things, but to show some comprehension of meaning. And that's really not easy to do. So let's look at the source document. And again, it does mention that language is indeed made up of arbitrary symbols, and that the animal will have to in some way show that he grasps the symbolic relationships between words and things. Now Premack believes that in order to really demonstrate comprehension of a language, you need to be able to demonstrate comprehension of concepts. And the easiest concepts to perhaps train in an animal would be something like same and different. And I'll just read this to you verbatim. According to Premack, demonstrating comprehension of the same requires a subject to recognize not only that two independent objects, call them A1 and A2, are blue, but that only a single attribute, the category color, is shared. The subject must also recognize that the attribute or sameness can be immediately extrapolated and symbolically represented not only for two other blue items, but for two novel items, independent green items, B1 and B2, that have nothing in common with the original set of A's. Wrap your head around that a little bit. We can't go this far in the study to see if, or we don't go this far in the study to see if Alex, the parrot, does recognize that the relationship between A1 and A2 is similar to the relationship between B1 and B2. But this is the sort of thing we're moving towards, okay? Pepperberg worked with Alex for many, many years. So this is a first step in trying to establish conceptual understanding of relationships. So the aim of the study is to see if an African gray parrot could use vocal labels to demonstrate symbolic comprehensions of same and different. Okay, and in order to do this, we need to find dimensions by which we could make comparisons of same and difference. So Alex already knew at the start of this study that there were five colors that he had. What are the colors again? They are green, rose, blue, yellow, and gray, and rose equals red. He doesn't vocalize everything perfectly, partly because of the mouth of the bird is different than our mouths. He knew some shapes, but he didn't know them by the name. He knew them by their corners, 2, 3, 4, and 5. It would be very surprising to hear a parrot pronounce a word like pentagon. All right, so that would be very difficult to do, not because he's dumb, but because his mouth doesn't really work the same way as our mouth. And the last dimension is materials. And the shapes and the colors took about 4 months to train, and the materials took 9 months to train. So why did it take longer? I think partly because the word matter was hard to pronounce. We'll talk a bit about that later on. So there are 3 dimensions. So in other words, if the question was asked, what's same or what's different, he should have a 33.333 chance if it was just blind luck. So we're looking for a number that's well above 33% to see if it is indeed just blind luck. And that's why we use 3 concepts instead of 2. 50-50 is probably a little too easy. All right, let's talk about the participant. Participant is super famous. He began study in June of '77. I don't know if he was born then, but he was probably rather young. He had free access to anywhere he wanted to go. He could express if he wanted to go to the gym. He was in a cage that was 62 by 62 by 73 centimeters. Now that seems like a throwaway detail. Why even include that? But remember that the laws for animal ethics are getting more strict, in the 80s especially. So you want to make sure you include this stuff in case someone's going to throw at you. Maybe there was an unethical treatment of the animal. And oftentimes Alex would actually request to go back to his cage. He'll be a little burned out, or he'd get a little frustrated at how much work he had to do that day. 8 hours a day might be a little long. But he would get anything he wanted. He always had continuous availability to food and water and things like that. Now, the sampling method, it would have to be opportunity. I don't think this will be a great question to ask people, what was the sampling method? But, this is the bird that Pepperberg happens to own. I don't think she asked for a self-selecting sample. She didn't go out in the jungle and say who wants to be part of the study. Like I said, Alex is super famous. He has a longer Wikipedia entry than Ham the chimpanzee, the first primate in space that we launched. So that just goes to show you how important Alex is for not just psychology, but it really touched a lot of people that there was a bird who had anthropomorphic qualities. People really connected with this bird.
Alex, what matter? Whoa, that's right. You're a good
Alex answered different questions about the same object.
How many colors? What shape? What shape?
Okay. That was early training. That's what early training might look like. Because we're not interested in him labeling stuff. We're interested in him showing differences. Labeling is the first step. Okay, so the early training was label acquisition, and it used what's called the model rival approach. And this is where Bandura gets into the study, having two people, modeling what they would like Alex to eventually do. So the training could take place you could think of it as a 3-step process for each list of items or each grouping of items. So one person would say to the other, what shape is this? She might say something like 3-corner, and then she would say something very positive, like very good. So the consequence would be positive praise, but also the person who answered correctly would get to keep the shapes. And so Alex might be the rival in this situation because he might be very jealous and he wants to get in on the action. He's like overhearing this conversation. And if he wants to, he could interrupt, and maybe he'll get the praise and he'll get the goods. He'll get the shapes that are on the tray or whatever. So Alex is being kind of tricked into being a participant in this way. And again, this is called the model rival approach. And you might say to yourself, why does Alex want to have these objects? They're not food. Why does he want them? What intrinsic value do they have? He was sort of a hoarder. He liked things, especially new things that he's never seen before. He was quite an inquisitive bird. So if he gets to keep the objects, he's very happy about that. Remember, he has all the food he wants, so giving him something like a snack might not be as effective as giving him something like a red piece of cork. He might find that really exciting. So this is the early training, label acquisition. Then we get to the later training. The later training is more of the task that we're going to be testing later. What's different? What's same? All right. And again, we have the model, the human model, trying to give an example of how you should respond to these types of questions. And again, Alex would interrupt. Now, what if you got the answer wrong? The consequence would be no, really loud, emphatically no. And then the objects would be removed. So it's the opposite. Instead of praise, it's condemnation. And instead of a gift, you're getting the objects removed. So that's the late training. And then we go to the actual where we're getting the data from. Now, I'm going to go to a different slide for this one. Where is that slide? Okay. We are going to put the trainer from the earlier sessions in the corner of the room. The principal trainer will stay in the corner of the room facing the wall. A secondary trainer, someone who's never worked with Alex before, maybe it's a student or someone, will be the one presenting the objects. Now, because he's not familiar with Alex, he might not understand Alex's vocalizations. So, for example, if Alex says something like mama, right, he's not going to know that means matter, perhaps, or he might mishear it or count it as incorrect. So the principal trainer, who's not looking at the object, she has no idea if Alex is right or if Alex is wrong, will repeat what she thinks Alex had just said. So this is a way to make sure there's no experimenter bias, and that's an easy way to explain this. But another way of saying this is that you can't accuse the trainer of cueing Alex. And what is cueing? Cueing is when you give like a nonverbal signal for a desired response. So a famous example of this would be the 19th century hoax of the horse who could do mathematics. This is impressive, even if it's not true that a horse could do math, because it took like 2 years for this German guy, Wilhelm van Osten, to train a horse to answer in certain ways by things he would do to signal the horse to answer. So maybe he's like scratching his right ear, and the horse will stomp an answer to a math question on his hoof. So while it's an impressive example of conditioning, it's really not an impressive example of genuine animal intelligence. So we don't want to have cueing. We want to make sure that that principal trainer is stuck in the corner of the room, staring at a wall. And please note that the first vocalization that Alex gave was what was accepted. So in other words, if he said 2 answers and the second one was correct, it was ignored. So this also helps with the integrity of the test. All right, so that's the majority of the procedure. There's one more element to the procedure that will add some complexity to the study, and it's not quite graspable the first time you read it, perhaps, at least it wasn't for me, but there were these additional tests that were used, and they call these probes. And how are the probes different than the other tests? In the other tests, if there was a difference, it would usually be on one dimension only. The probes, however, would have differences there were 2 differences. And the reason for doing this was to make sure that Alex was actually attending to the questions. So what does that mean? That just simply means that Alex might just be responding to the objects themselves rather than listening carefully to the question. So he might say to himself, wait a second, the only difference here is color. They probably want me to say color, and they give it to me. So just to make sure he's paying attention, he's processing this information, they would do these trials that were with 2 objects that had 2 similarities. That's all that really means. What's really impressive about this is that he actually did better on these than he did on the testing questions that were, the main data. I believe he got 90% of these correct. So in short, that shows us that Alex was indeed listening to the questions. He wasn't just responding to the objects. So we're kind of getting into results here with that 90%, but the main results have to do with the how many he got right and how many he got wrong. And in the study itself, it actually puts down in the results how long it took to train as well. So you could put that as procedure, but in the study, it's actually put as a result. So to acquire the colors and the shapes, it took 4 months, and I'm using the American spelling for color here because it's written that way in the study, and 9 months for matter. And again, they say that it doesn't necessarily mean that matter was more difficult, but that it took a while to grasp a new phoneme. The word phoneme means the units of sound within a language. So it says here, in addition, vocalizations that involve novel phonemes take longer to train. And as we discovered that earlier, he couldn't say the word matter. He was not able to put all those phonemes together. And again, just for clarification, a phoneme is the smallest unit of sound within a word. I believe English has 44 phonemes. Last time I checked. All right. Results. So there are lots of numbers here. I think there are some numbers that are relatively easy to remember. Taking all this data and just kind of whittling it down to 2 numbers might be easy enough for our testing purposes in May. And then after May, we could forget about those numbers. But what's really interesting is that for familiar objects, things he had seen before, he was slightly lower than for novel objects. Maybe not too slightly, it's 8% lower. So for things he had never seen before, he was more, I guess he was more determined. Some people suggest that he did better because he was motivated to have new objects in his collection. So he's more attentive. Oh, I got to get this right. I really want that item. I really want that shiny, hair clip. That excites me. So, Alex is a hoarder, and he might be getting tired of having just cork in his collection. Maybe he wants something new. I can't speak for Alex. All right, so let's interpret the results, and that's actually the conclusion that Pepperberg came to as well. So here she says he may have had some more incentive to pay closer attention to novel objects. So even though it seems contrary to our initial guesses about what the results would be, the new objects were more identified as same or different. All right, let's get to the conclusions. A very simplified way of putting the main conclusion is that the concept of same or different can be grasped by non-primates. So the challenge that David Premack had set before us of can a non-primate have a conceptual understanding of things and represent that concept symbolically or through language has proven to be not true just for primates. Maybe birds could do this as well. However, some of the tasks that David Premack had set before us were not tested in this study. So, for example, finding analogs between sets of items, and we come back to this example of A1 and A2 and B1 and B2. So, is he able to say what the similarity of relationship is between the first two items and the second two items? That might be something for a later study to consider. So like most studies, there are ideas for how we can make the study even more thorough or more conclusive about the cognitive abilities of animals. All right, so I think the study is understandable. However, it does require a little bit of linguistics and maybe a little bit of depth of thought for what makes something truly intelligent. And in that regard, it makes it somewhat philosophical. Is Alex truly a sentient being with a consciousness? Also, I think this piece is very interesting too because the footnotes, I usually tell students don't look too carefully at the footnotes, but the footnotes in the study are actually really interesting. For example, he would be quite inquisitive about colors he had never seen before, and he even one time looked in a mirror and wanted to know what color he was, and that's how he learned the word gray. So he's an African gray parrot who learned the word gray relatively later than other colors. Also, he's quite creative with language. He sort of creates his own vocabulary based on what he already knows. So, for example, if he sees a kernel of corn, like a popcorn kernel, he would call it rock corn because it's corn that's hard. Or if he sees an almond, he came up with the word cork nut. So even though sometimes people thought, oh, Alex was wrong, he gave the wrong answer for what this is, in his own mind, it was the right answer. And, compound words are part of almost every language. I think of Chinese, where you take words that are separate, put them together, and now you have a new word. So, for example, in Chinese, 面包车 means bread truck, and it's a truck that's shaped like a loaf of bread to move your furniture. I just find stuff like that interesting, how you take two separate words and you push them together, and they become something new. All right, so let's evaluate this. Before we evaluate this, let's look at this list in the appendix. This list is of the pairings of objects that were in the novel conditions. Now, they made sure they were so careful with the objects. They actually categorized and labeled and listed and kept copious notes about what was used in what combination. And the reason for this was they would try to avoid putting things together that he had already seen in that combination. So it's keeping everything novel. All these situations are novel. He can't just use memory. He can't rely on memory to answer these correctly. So this is quite impressive. It just shows you how much work goes into studies like this. So if you look at the first pairing, for example, 5C WHP, 3C WHP. So, without a key, I would imagine that means 5-corner white paper, 3-corner white paper, and that was assessed by difference, and he gave the response of shape, which is correct. Okay, 5-corner versus 3-corner, or pentagon versus triangle. So again, this is not just showing us how much work went into this, but if you wanted to replicate the study, you have a recipe for what pairs and combinations were used. So this affects the evaluation in that it was really tightly controlled, I think to the best of their ability. So I'm giving this a very high arrow for reliability. Now, generalizability is going to be a problem. It's only one parrot, but at least it helps us with the ethical consideration of numbers. We're using the least amount possible to make the study somewhat useful. I don't think I don't know, maybe I'm too low with that arrow. Would it apply to other parrots who are in captivity? And the evidence is yes, it does. There are other parrots after Alex. When Alex passed away 10 years ago, which was very heartbreaking, I think Pepperberg bought another parrot named Griffin. And Griffin has similar abilities to Alex. So yes, there is replication with other birds, but within the study itself, there's only one bird, and he's not a bird who was raised in a natural habitat. Application. Well, one of our textbooks suggests that one application could be, now that we know that we can model behavior for animals before introducing them to a new habitat or maybe a zoo or something like this, you could actually use social learning theory to train animals how to behave in certain contexts. Maybe that's a bit of a stretch, but that is in one of the official textbooks that we use. Also, just in general, training to perform certain tasks gives us a recipe for how to train non-primates to do certain things. All right, the validity, easiest one to talk about is ecological validity. I think the validity study is okay, but ecologically speaking, it's a lab study, of course. It's a very controlled situation. Would most birds be exposed to these geometric shapes in nature? Probably not. So, I think that one is easy to gauge on an ecologically valid basis. And in terms of ethics, I highlight this one in red because, again, we're not dealing with the typical ethics here. Was Alex debriefed? Probably not. Did he have the right to withdraw? Well, kind of. I mean, if he wanted to go back to his cage, he would sometimes say back to cage, and that was the end of the day. However, this is something new for psychology. The psychology syllabus is that we have to think about animal ethics. And I think three things to think about are housing. The housing was quite good. He had free access to the entire facility. He could request to be taken out of his cage or put back in. Number, one is a very low number. And the use of rewards versus the use of aversive stimuli. Now you could say, well, being shouted out with no is an aversive stimuli, and that's somewhat true, but it's not terribly distressing beyond a few moments. So he wasn't shocked, he wasn't physically hurt in any way. He might have had his pride hurt a little bit, but that's about it. So the rewards were there. He got everything he needed. So I think those are three things to think about when you're judging this in terms of ethics. Okay, so let's move to the last stage of the slide. For the students who are watching this, please answer the following three questions for the next lesson. They're all 4-pointers, so it's a 12-point homework. To what extent is the study reliable? Describe the model rival training for the concept of same or different, not for labeling, and explain how guidelines for the ethical treatment of animals was followed in this study. Remember, when you see a describe, detail, detail, detail. When you see an explain, make sure you link it to the study. So don't just say there was good housing. Link it to the study directly. Give a bit of detail from the study that links to what you're talking about. This is a large problem for a lot of students. They look at the questions, they give the shortest possible answer, and then they're out of luck when it comes to grading. Don't rob yourself of the things that you know. You know this stuff, you just don't want to spend the time. And I say you, I mean a general you. I'm sure there's a lot of people here who are doing quite a good job with these. All right, so I'll see this homework next lesson. Have a good day.